Hi, I'm Aaron Edgecombe, and in this presentation I'm going to be presenting on circuit parameters and parameter sweep in NI Multisim. Circuit parameters are schematic values that we can use to set the value of components and key variables in our simulation. To understand how this can help us teach theory, we are going to consider understanding a simple resistor, capacitor and inductor filter. Two important variables that affect the circuit are the cutoff frequency and the quality factor. We are going to use circuit parameters and the improved parameter sweep to gain an understanding of this core concept. Here we can see the schematic which I've created in Multisim. At the moment, all the component values are based on fixed variables. Using circuit parameters, I want these to be tied down to these circuit level parameters. First off, I'm going to open the Circuit Parameters window by going to View, Circuit Parameters. Within this window, I can define any parameter I want to be based upon these variables. Firstly, I'm going to define my cutoff frequency. I'm going to set this as a fixed value of 15 kHz. I'm also going to define my inductor to be a fixed value, and in this case, 10 micros. You can see that I need to enter a name for my variable, give it an expression which can be a fixed value, and then we also have the option to create a comment. I'm going to add in there my quality factor, which I'm going to set to be 0.8, and now for my capacitor and my resistor, I'm going to have these variable. So my value for my capacitor and my resistor are going to be based upon the cutoff frequency, the inductor, and the quality factor. Now to do this, I'm entering an expression for these. So these will be generated dynamically dependent upon the values I set for my cutoff frequency, my quality factor, and my capacitor. Here you can see I've got my expression for my capacitor, and now I'm entering my expression for my resistor. Once we've assigned these, we can also see we get a preview, and that preview shows us what value is assigned to that variable. We then need to tie these variables down, these circuit parameters down, to our actual components. So in the properties field for the inductor, I'm typing in the name Al to correspond to that circuit parameter. I need to do the same, so C for the capacitor, and then for the resistor we need to give it the value R. That links together our circuit parameters with our actual components in our schematic. A really useful feature is the preview. So if I change my cutoff frequency to say 10 kHz, you can see my capacitor and my resistor change dynamically. Let's return that to 15K, and now let's have a look at the response of our circuit. First, let's run an AC analysis, so we can see the frequency response. We'll keep the frequency parameters set to default, and we're going to look at the voltage output, which you can see is the output of our filter. If we simulate that now, you can see the response we get from our circuit, and we can see that we're getting a cutoff frequency of 15K, which is what we were aiming for. Let's say we want to understand more about the quality factor. To do this, I'm going to run a parameter sweep. Now the variable which I'm going to use is going to be a circuit parameter, so I'm going to essentially sweep through various values for Q. I pick circuit parameter, I select the circuit parameter which will be Q, and I'm going to pick a fixed list of values to go through. We're going to do the same AC analysis as before, but just using these different variables, and we're going to look at the voltage output. Once that's complete, you can see the resulting output. We can see that as we vary the value for Q, we get a different response from our circuit. This allows us to gain a really good understanding of what difference the quality factor makes on our actual circuit response.